In this video, I connected with Dr. Andrew Wheeler, a former crime analyst in Troy, New York, and an end-to-end data scientist in the private sector, working on fraud, waste, and abuse in the healthcare sector. He holds a Ph.D. in criminal justice, so I asked him to talk to me about crime analysis techniques for smarter metrics and other useful methods he's found useful over the years. This is how it went.
Yeah, thanks for having me on, Mandy. So just for a little background on myself. So currently I'm a data scientist in the private sector, working with healthcare claims on fraud, waste, and abuse. But where we overlapped is I used to work as a crime analyst. So got my PhD up at Albany, New York. And while I was doing that, a PhD in criminal justice, while I was doing that, I worked as a crime analyst at Troy, New York. And then my research was all about working with police departments and doing quantitative projects that essentially were applied research projects to do crime analysis with police departments. And so we've probably met at the IACA conferences over the years, given talks there. But essentially I do number crunching type stuff, research analysis with police departments. And so more currently, like I said, I'm working in the private sector and healthcare doing fraud, waste, and abuse. But I still do consulting projects with police departments. So crimedecoder.com, as you can see, sort of I'm plugging my consulting firm in the background. But thanks for having me on, Mandy. I can't remember the different conferences, so it would have been a few years ago. But I'm pretty sure I did I'm trying to remember. I think I did like one of the hour-long like tutorial sessions. And so it wasn't in the computer lab, but I had the screen flashed up and essentially just showed individuals how to do in Excel. Essentially, I was critiquing the main types of ways that we do CompStat reports. And it was really just about that percent change. And so I really hate that. If you've ever been in a CompStat meeting and somebody's like, well, crime year over year is up 200%. It's like that, but don't ignore that number because it's like a small baseline. That's essentially what this whole particular paper was about. So I discussed ways to do smarter metrics, essentially for those particular CompStat reports, essentially doing what I call a Poisson Z-score, looking at changes in crime over time that behaves better with both small crime counts as well as large crime counts. But really one of the big takeaway messages is that people should just be using line graphs to show temporal trends over time. Like, don't even worry about doing the percent change metric, essentially. To back up a little bit, I know we're quantitative enough among the crime analysis community here to talk about basically like the normal distribution that you hear about, that you learn about in like your introductory statistics class. And so you have a mean, you have a bell curve, you have a mean and a variance. So you do some measure over time, and let's say it's just an individual's weight. And so the weight will fluctuate a little bit here and there over time. And so your weight may be 150 pounds in the standard deviation, maybe 5 pounds whenever you do your measurements over time. So when we're talking about counts of crime over time, it doesn't really matter what it is. It's never going to be exactly the same. So this month maybe 10 crimes, next month maybe 12, next month maybe 8. And so you're monitoring these particular crime counts over time, and they're going to fluctuate a little bit, even if essentially the underlying mean trend of those particular crimes is flat. They're not going up or they're not going down. And so for Poisson metrics, which are essentially just things that you do counts of over time, we know that their variance essentially equals the mean. And so in real life statistics, whatever you're measuring doesn't ever exactly conform to a theoretical distribution in real life. But in practice, when we examine crime counts over time, they tend to follow the Poisson distribution close enough that we can essentially know what those typical ups and downs are. And so, based on those typical ups and downs, we can essentially generate charts or graphs or know what is like a significant change in those crime counts over time. So, going from 10 last month to 15 this month may not be a significant change, but going from 10 to 20 may be a significant change. And we don't even need to have like multiple measures over time. You can just know the pre is 10 and the post is 20. And based on that Poisson distribution assumption, make reasonable estimates of whether crime is significantly going up or down. When I worked at Troy, I would come in every day, and Troy's a small enough city that I could just go through all, typically like around 50 incident reports, like 30 to 50 incident reports from the prior day, and just so I could look at essentially all the different crimes that are being reported on a daily basis. But from a crime analyst perspective, it's really hard to know if we had 5 burglaries yesterday, is that anomalous? Is that indicative of, a lot of times we're talking about like a single criminal group can go and shift up crime stats for the whole city, even in larger cities. Troy's a city of about 50,000 individuals, but even in larger cities, a single group can cause that a spike overall citywide crime. And so a lot of what we're doing as crime analysts is looking at those trends and trying to see if there's like an itinerant group that's causing that particular anomalous uptick. And then you go to the detectives and be like, look, these particular crime incidents are likely related. But in that first step, identifying if there's an anomaly over time, that's what this particular paper is about. So it's like understanding what the typical background variation, understanding what are typical ups and downs, so you know when there's an anomalous increase. For the percent change metric isn't a good way to know that, because like I said, if you have a small baseline going from 5 to 10, an 100% increase isn't necessarily that informative, because that could even happen in basically random Poisson data. My research when I was still, I forget if I was a professor at that point, but I got my Ph.D. at Albany. I was working with my advisor at Albany, Rob Warden, has a nonprofit Finn Institute. And the Finn Institute not only does research collaborations with mostly police departments in upstate New York on very crime analysis type stuff, but he also employs via grants through the New York State Division of Criminal Justice Services crime analyst folks to work in the different crime analysis centers all in upstate New York, if you're familiar with those. So essentially I worked, and that was my job at Troy, so I was technically paid by the state. And I think that all those crime analysis centers are really great sort of examples of crime analysis. But to make a long story short, after I got my PhD, I went and worked I was a professor of criminology at the University of Texas at Dallas. So did some collaborations with the Dallas Police Department as well as Carrollton PD. One of the projects I did with Carrollton is optimizing patrol beats. So making patrol beats, basically using a spatial algorithm to identify patrol beats so it takes less time to drive to the calls, as well as makes the patrol beats. For Carrollton, they had like single officers cover a particular area. And so over time, they had patrol beats that were uneven. So some officers were taking almost twice as many calls as other officers, depending on the spatial area. So I essentially developed an algorithm to help them not only make the beats optimal, but also make the workload equal for officers. It's a common sort of mathematical algorithm, and it's essentially, it's more in the area of people commonly call operations research. And so that was what's called a mixed integer linear program. It sounds complicated, but really, if you sit down, I can give a book recommendation, you can figure it out essentially. And so it's really taking what the police department needs to do, and it's not just for the patrol beat analysis example, but it can be for a lot of different allocation strategy problems. So it may be like determining you have finite resources to assign detectives to particular cases. You may try to do a particular optimization algorithm to determine when you should assign a case or not, distribute those finite resources. And it's essentially not that much different. To make it mathematically tractable, you have to make some simplifying assumptions. So for example, that particular one, I don't consider the case where officers are randomly distributed. I only consider the case where officers are dispatched from a central location. So that's more akin to the way that like ambulances or fire departments work. But I think that that's like a reasonable approximation to essentially give the police department not necessarily a perfect solution, but one that's reasonable as well as accomplishes that workload balance essentially. So I know that that's a more complicated way, and anybody can always feel free to send me an email. I'll send you the paper, send you the code associated with those papers as well. But it's one of the things that I really like, and I know this is sort of like me and you are a good group, and crime analysts are a good group to nerd out on some stats and coding and stuff like that. So I took historical calls for service, and then that essentially informs your expectations for what the workloads are going to be in the future. For Carrollton as well, one of the things that I did for them is they also had questions. They're a growing city, so a lot of these locations in the South, are just expanding like crazy. And so they also wanted to know, like, if we zone for more like the larger grocery stores, like if we do one of these big box stores, how many calls for service is that going to increase? Or if we do more apartment complexes, how many calls is that likely to increase? So I did some of that work to try to do like reasonable short-term projections for them. And then based on those, essentially you just chunk up your city into tiny areas and then have the computer sort of conglomerate, district them into response areas where a single officer will be responsible for calls in those particular areas. I think it's a good sort of example in terms of it's really common sense in terms of like trying to equalize the workloads. And even in that particular paper I wrote, I gave examples of how it can be that you have a particular hotspot get split up in between two different patrol beats. But in the end, that may be good because essentially you have multiple officers potentially basically working that one particular hotspot. And so it's distributing the workload, I think, is ultimately good in those scenarios. And if you had a location that I've done some other work, and this was with Dallas PD, essentially sometimes you have areas of the city that have so much crime, so these hotspots of crime, that it makes sense to just assign particular officers there full time. They have so many crimes that it would make sense from the expected reduction you would get from hotspots policing. They should devote officers to those small areas full time. To back up a little bit, we're talking about all of these different so linear programming to optimize patrol areas, or doing GIS analysis to do hotspots. One of the things that I think is really good for crime analysts, and it seems like a lot, but essentially to get more fundamental data science skills so you can understand and apply these particular algorithms, whether it's GIS algorithms or optimization algorithms, to the idiosyncratic problems that police departments are facing. And this was another example project I did when I was in New York. And this was, if you're familiar with group violence interventions, or more common terms for them is focused deterrence. David Kennedy's group is the main one he was the originator of the idea. I'm pretty sure his group is out of John Jay at the moment. But essentially that particular intervention is you do call-ins for gangs. And then if a singular member in the gang does something like a triggering offense, so if a gang member shoots at a rival gang, or some cities, a triggering offense can be a stabbing as well. The police department, in coordination with the DA's office, sometimes with federal prosecutors as well, will go after, essentially pull all levers to go after the entire gang. And so part of that particular intervention is, like I said, you call in individuals in the gang. So you do a group meeting with multiple people at one time. And essentially the way that those meetings go is you go around the room to the different criminal justice practitioners, and they talk about the deterrence aspect is basically going through examples of how they went after entire groups at once. So you say, like, so you give a clear message. So if you're smoking weed on your doorstep, we don't really care. We care about if you commit violence against a rival gang. So you have like this clear message of what's okay versus what's not okay. And then you have like what's gonna happen if you mess up. Those particular call-ins, you often can't call in the entire gang. So they may be limited to like 5 or 10 individuals. And so I developed an algorithm. You look at the connections between members of those gangs, and then you try to identify the best seeds. So you want to call in those seeds to those call-in meetings, and those seeds are located in the social network in a way that they're you would expect the optimal amount of spread without having to go through any intermediaries. So if you're familiar with the telephone gang, as kids, you don't really want person A to talk to person B and then person B to send the message to person C. You want as direct messages to as many people in the group as possible. And so that algorithm was essentially identifying the optimal individuals to seed that message throughout the rest of the gang. So the algorithm in and of itself is what's called a greedy algorithm, and you have technical terms for stuff that are ultimately simple. It's essentially, I take the individual, I just do an iterative algorithm. I take the individual that's the most connected in the gang at first. And so that person will then spread the message essentially to all of their first degree connections. Then essentially I just cut that particular person out of the gang because I've already given them the message, and then go to step 2 and then do the same process over again. So I try to find the individual who is likely to spread the message to the most remaining people in the gang after that. And so it's just an iterative algorithm. So the step 1 will ultimately, the person who gets the most weight at the step 1 is the person who's the most connected to the most individuals. But after step 1, it just depends on the leftover people who haven't been reached in the particular gang yet. So you could have like isolated subcomponents of the network, and so they aren't connected to as many people, but one of those people in those subcomponents should be called in. So you know that you spread the message to that like more isolated component. And then sometimes it'll be, if you're thinking about a network graph and it's spread across the page, and maybe you call in somebody, on this side of the network, and then it's best to call in somebody on the other side of the network. And so networks don't really have sides, it's just how we arbitrarily represent them on a piece of paper. But it's essentially just trying to spread out the messages. So you reasonably think that all of the individuals in the gang are likely to know about that deterrence message. To back up and go to a more basic lesson, I'm sure IACA has like a white paper on social networks. I know that there's definitely a chapter. I have our book here somewhere here in my office, but so go check out those particular posts on the IACA to get sort of your feet wet in understanding what social networks are. But I've also done a primer post on my crimedecoder.com website recently on sort of like I called it a primer on social network analysis. And so for very new crime analysts, so what is a social network? It's not necessarily like, it's not looking at Facebook posts. most of the time when we define a social network among offenders, we're looking for ties in those administrative records. And so those particular groups that I created that algorithm for, we define ties as you're either arrested during the same incident. So two individuals committed a robbery together or burglary together, or you have a field stop at the same time. So if you've been stopped in a vehicle and you're all in the vehicle together. So essentially you have these linkages based on administrative data. And so we can know that person A has been associated with person B in these very specific sort of scenarios where they should clearly know each other. I don't know about you, Manny, but I don't tend to take car rides with people who I don't know very much besides getting an Uber ride to the airport. So we know based on administrative data that these two individuals know each other. One of the most interesting things about looking at networks of gangs, and gangs don't necessarily need to be like these uber organized like Italian mafia from the movies type things. It can just be just like a group of kids essentially who hang out and deal drugs and get into trouble. Essentially, when we graph those particular network gangs, they're not hierarchical. So it's not like a single person is connected to everybody else. They're not like a business plan essentially with a CEO. You get these very complicated patterns that are all like spread out. And even people who are associated in the same gang, you'll oftentimes get networks that they're not, you have like 3 or 4 degrees of connections before those two particular individuals are tied together via this administrative data. So for that particular analysis that I did, between field stops and co-arrest, I didn't make any particular distinction about. But to flip it a little bit to the more general question, like what do I do with this particular information? The way that I think about it is that you have to have some ultimate goal of what you're going to do with the information. It's not like whether we're looking at a social network or we're looking at crime trends or opening up an Excel spreadsheet. Like the Excel spreadsheet doesn't sing to you and tell you what you need to do with that particular information. You should already have in mind particular goals that you want to accomplish with the analysis, and in particular supporting police departments. Or we're talking about police stuff here, but it could be really anything. It doesn't have to be specific to police departments. You should have a goal in mind for the analysis before you start, because you're not going to look at the social network and it's not going to give you the goal in the end, essentially. And so here, that particular tool, that prioritization algorithm that I gave was essentially for that idea of you can seed individuals to spread the message. And so that particular algorithm can be applied not just for the group violence interventions. Sometimes people do house visits. So I know Buffalo PD was doing something like that with their, essentially working with the community, the violence interrupter. So the former gang members that go out on the street. And so they could use that algorithm to identify maybe good people to go out onto the street to essentially talk to. Another example, not necessarily directly in crime analysis, but for public health folks, they've done particular programs where they will go out and safe needle exchanges, and they'll give information to particular individuals and have those individuals essentially collect needles. And so that's sort of like another example where it's that idea of the seed. So you can do a few different things with social network. A lot of times if we're thinking about doing investigations, we're thinking about like removing a node from the network, but that's not what this does. This is like finding, you're assuming you're trying to get a measure of the network and figure out the best way to spread the message, essentially. It's almost like the opposite of spreading diseases. There's something good that you want to spread through that particular network. But in terms of the more general, like what do we do with social network analysis? Here's like another example I like to bring up. When I was at Troy, the captain of the detectives there, the detectives joked about him being a bit of a micromanager about it, but I think they liked it in the end. And one of the examples they gave was that, so Bob assigned me a detective case because I worked a case with that individual's cousin 3 years ago. And so essentially he just had like in his mind, he had like that network effect in his mind. And so he would assign particular cases because that detective already had a rapport with individuals associated with that case. And so that's just like another random example of where actually drawing the network can help inform particular decisions that the police department may want to undertake. So instead of, if you're a detective bureau, especially at a smaller department in which detectives are going to have, a single detective is going to have to handle all the gamut of cases. You're not going to necessarily have a detective specifically assigned to burglaries or robberies. It may make sense to assign them based on their connections to individuals within that network, or their relationships to past cases within the network. In that highest score can be tailored to whatever your particular application is. So if we're thinking about in terms of preventing retaliatory violence, like what those violence interrupters, sorry, I'm getting my terminology wrong, but so those former gang members that go out and talk to individuals, you may want to do the ties not based on like your friends, but you may want to do it based on the enemies. So you may want to identify the individual. So if there's been a shooting or a victimization of one individual, you may want to proactively identify the individuals that they're going to go after in retaliation to try to mediate that before it starts. And so in that scenario, it may make sense to not look at ties that say that they're friends, but ties to say that they're enemies of each other. You can ultimately use both intelligence-driven data as well as the admin data. So a lot of police departments will have a gang intelligence officer. And so most of my experience is that the labels of whether an individual is associated with a gang often comes from that gang intel officer. So that's not something that's often like explicitly articulated in the RMS system. Sometimes it will be, but most of the time not. And so that gang intelligence officer will often use street intelligence to identify if an individual is associated with a gang. Like they'll just be out in the street and see people hanging out, or they'll talk to somebody, or they'll see somebody like wearing the colors or whatever. So it'll be, that part might be intelligence driven. But a lot of what we do as crime analysts is like digging into that admin data, and that's really where our value add to the organization is, to be able to take those 100,000 stops that your police department has recorded over the past 10 years and then identify those linkages between individuals, whereas somebody the Captain Bob can't necessarily like know all of those 100,000 links, but you can go and look at the actual data, look at the actual associations, and be able to draw those particular networks. Crime analysis is the use of statistics to help police departments reduce crime. And so it's essentially number crunching to help police departments make decisions to mostly focus on reducing crime and be more efficient. It's definitely hard, and it's not just crime analysis, it's any sort of quantitative work. And so my particular advice is, don't wait for people to come and ask you for things. Like, you're the expert. So you're the expert with databases, you're the expert on numerical analysis. And so you have to be really have to be proactive. And my experience is that command staff appreciates that. If you're not in a place where command staff appreciates that, like, you should look for a different job, essentially, because like you can't, there are places who appreciate your skills and you should go to those particular places. But you can be proactive, and you need to understand what's useful for the police department. But if you go to those command staff meetings, if you go to those comp staff meetings and you're like, hey, look guys, there's these car break-ins at these 3 different locations. I think it's like the same group of 3 different people based on the particular incident reports. Like, we need to get our stuff together and go figure out a way to prevent these car break-ins. It's not like stuff like that will totally get lost in the shuffle without you doing the numerical analysis, identifying those trends, identifying those groups. So you have to be proactive and bring information to the police department that they can act upon. But my experience is that if you command that room, essentially, you can make that difference and you can get people to pay attention to you. But if you just wait for people to request stuff from you, yeah, you're going to be a query cleric, essentially. I think one of the areas that I would like to see more education on is essentially, we're talking about optimization. I think that there needs to be not necessarily more training in stats and number crunching, but more training in more basic programming. And so, really, like, you flashed up my tool to do the social network algorithm, and I've talked about doing optimization for patrol districts and stuff like that. The reason I'm able to do all of these different algorithms, these different projects, is because I know computer coding well. So like, I know how to go in Python and do a greedy algorithm for a social network, or I know enough that I can teach myself those particular skills later on. Those skills have so much worth, so much utility, not just in crime analysis, but for any particular business. So being able to automate that crime stat report, once you automate that, you don't have to spend a week every month doing that report. Once you click the button and it pops out the report and it's done, and you can go on and do other things. And the skills to do that, to be able to fully automate workflows, really translates to opening the box. You don't need to buy somebody's predictive policing algorithm. Like, you can do that yourself. Like, you can open up R, you can open up Python, and you can build that predictive algorithm based on your own data for your own police department. And that's based on learning coding, essentially, learning Python or learning R, learning SQL. And those skills like translate into the private sector too. It's the same in basically any data analysis, data science type role. And that's where I see a lot of different analyst units sort of lacking behind. So that answering a little bit different question of whether crime analysis is being underutilized in law enforcement. But part of it is technical skills as well. So people who can do skills like that can go get a job in the private sector, data scientists. And so it is definitely up for cities to be able to up their game, to be able to hire analysts to do those types of skills too. I have mixed feelings about ChatGPT, as I'm sure that most people do. I think ultimately in the end, ChatGPT's role will be, I think it is potentially transformative, but it'll be transformative in the way that Google was transformative, and it'll be sort of like a next gen Google search engine. And so instead of just doing a search engine and getting back your top ranking of web pages, it'll almost be like a summarization of those particular web pages. And so one example I was talking about with a few different friends the other day was the potential to do essentially qualitative analysis. So I told you at the beginning, I would go in every day when I worked at Troy, read the reports from the night before. I think it's possible that you could like feed that textual information to something that looks like ChatGPT and have it summarize the information for you. So you don't have to read 100% of the reports. Give me the cliff notes, ChatGPT. I think it's possible that ChatGPT could similarly be used in a capacity that's like problem solving. So say, okay, I have this recipe of a few different problem solving tactics that are common for police departments. feed it in the particular incident narratives at a crime hotspot and say, what do you think is the best way to tackle these particular crimes? I think it's possible that things like that could be built on the backbones of ChatGPT, but I don't see anything like that. And definitely, if you're a crime analyst, don't be putting your incident narratives in the OpenAI ChatGPT, because that's law enforcement sensitive data. And so a lot of these things, they're going to need to be deployed locally or in an environment that is okay for sensitive data. A lot of the stuff that you see online doesn't meet that particular criteria at the moment. So right now, that's not going to be feasible with ChatGPT. Thanks very much for having me on here. Like I said to folks, always feel free to reach out. We have a community of nerds that you don't necessarily get in the office, and so it's great to just go and chat and about whatever, whether it's ChatGPT or social network analysis. So always feel free to reach out. I think it would be great to talk about actual like real life use cases, and so I think it's good to describe just the little test that you just gave it. Describe like real life use cases, because when you have those, like I said before, you open up the spreadsheet, it doesn't sing to you, it doesn't tell you what to do. ChatGPT doesn't tell you what to do either. You have to prompt it, you have to tell it, you have to sort of give it guide rails, and then whether or not the quality of that output meets your particular standards, I think will probably change depending on those end goals. And so I think that would be a great discussion to have with working analysts.
That's Andy Wheeler, data scientist, consultant, and former crime analyst. You can read his blogs at andrewpwheeler.com and his consulting website at crimedecoder.com. The link is in the description below. Thanks for watching this episode. Click here to watch our other videos, and let me know what you think in the comments below. And do me a favor, hit that like, it really makes a difference.